Good morning, boys and girls, and welcome to Tuesday morning's math lesson. I've missed you. I hope you had a wonderful evening last night, and today we're going to get started on our math lesson. So last week we were doing Chapter 12, Geometry 12.1, 2, and 3. So we're going to continue on. We were talking about lines, we were talking about angles, we were talking about 90-degree angles, we were talking about acute angles, which are less than 90 degrees, and then we were talking about obtuse angles, which are larger than 90 degrees. We were talking about plane figures, which can be open or closed, and it can be curved. And then we were talking about polygons. And polygons are many-sided shapes, but they are made up of line segments, angles, and they have to be closed. So I just wanted to review a little bit before we get started today. Today we're going to be talking about describing sides of polygons. And so this is kind of fun, and you guys can do a lot of different things. You guys can make all kinds of different shapes now, and looking at different angles. You can look through your house and you can see all kinds of different shapes and angles. And then you can also start looking for lines and how those line segments become different sides of polygons. So looking right here, it says look at the polygon. How many pairs of sides are parallel? So the first thing we have to do is review a little bit. So if you think about parallel, I know we've been talking like this. You guys know parallel. Okay, and we've done that before. We've done horizontal, vertical, and we've talked about parallel before. All right, so if you think about parallel lines, you could think about out on the road, how the yellow lines go down the center. And so you have sidewalks that are parallel, one sidewalk on one side of the street and another sidewalk on the other side, and those would be parallel. So if you look up here at this right here, so you can see, I'll get my pen with straight line here. So you can see that we have different sides here. So we have a green side and a blue side here, and those would be parallel to each other. And then if you look here, you have a red side and an orange side, and those would not be parallel, because if you drew this line out, I'm going to get a straight line here for you to see. If I continued this line out, that would then intersect with this, and then that actually forms a trapezoid, which is a quadrilateral. Whereas if I continued this line and I continued this line, they would never intersect. The green and the blue would never intersect because they are exactly running parallel to each other. Whereas the other two lines, this one's at an angle, and that angle, if you drew it out, would make an intersecting line. So that takes us down to another type of line, which is an intersecting line. So lines that cross or meet are intersecting lines. Intersecting lines go and they form an angle. Okay, so right here is where they intersect. Okay, and they form angles. So you can see here that this would be an acute angle, this would be an acute angle, but this right here would be an obtuse angle, and the bottom would be an obtuse angle. So you have intersecting lines that form angles. Sometimes they're 90-degree angles, and we're going to talk about that. That's a very special intersecting line. Other times they make acute and obtuse angles, and those are the intersecting lines. Our next one is the orange and the blue line segments meet and they form an angle. So they are right here. So those are intersecting, because if I drew this out again, you would see if I drew this line out and I drew this line out and I continued those lines on, they would intersect right here. Okay. Whereas up here, if we looked at this line and this line, they continue on and they are parallel. They do not intersect. They go right next to each other. All right, another very important intersecting line. It's a very specific type of line that intersects, and it's called a perpendicular. And they cross right there, and they form an angle, but it's a 90-degree angle. So intersecting lines that cross or meet and form a right angle, those are called perpendicular. Anytime you see an L or a little square in the center, you know that's a very special line. Those are perpendicular lines. So right here, if you look at this blue line and this red line, they form an angle and they form a 90-degree angle. So this is perpendicular. Okay, so that would be perpendicular. This angle here, they would continue on right here, and they would continue on here. And so you can see this is perpendicular because you could form a little square there. And if it's a 90-degree angle, then it's perpendicular. All right, so we're going to continue on for lines. Lines that never cross or meet are always the same distance apart. Those are parallel, and you can see that these continue on straight and they would never intersect. So the polygon above has a pair of parallel lines. Right here, this polygon has parallel lines. And you can see that it only has one pair. So I'm just going to make a number 1 here. Sorry if it's an arrow. So that only has one pair. So just one. Fix that for you. Has one pair. All right. Now the green and the blue line segments, so there's the green and there's the blue, they will never cross. They are always the same distance apart, so they are said to be parallel lines. Okay? All right, so we've moved on to the next page, and so now we're going to try this. We are going to, up at the top of the page, hopefully you can see it. Put it over for you. It says, draw a polygon with only one pair of parallel lines. So parallel looks like this, so they do not intersect. So you want one pair. So first of all, you have to know that a pair consists of two things. So like a pair of shoes, you don't have just one shoe, you have two shoes. So you are going to draw a polygon with only one pair of parallel sides. Then draw a polygon with two pairs of parallel lines. Outline each pair of parallel lines with a different color. So we are going to go over and let's see, give you a second to get a pen. I need to get something that's a straight line here. All right, so first one says draw a polygon with only one pair of parallel lines. So I'm going to start here at the top and I'm going to draw one here, and then I'm going to draw another one right here. But I'm not going to make it as long because it wants a polygon with only one pair of parallel lines. Then draw a polygon with two pairs of parallel lines. Okay, now I can't outline mine in different colors. So here we go. You've got right here and right here. Let me see if I can try to change it. All right, so then we'll go to red. Okay. So we're going to go here and I'm going to draw up. And then I'm going to draw down. Okay. And then I'm going to go across. So you can see right here that I only have one pair of parallel lines in this polygon, which is a closed-sided figure with multiple line segments that connect. But this one right here is not parallel to this one, because if I extended this line out, you would see it would cross. Okay. So now I'm going to draw a second polygon with two pairs of parallel lines. So let me go, I'll get another color here. We'll go with blue. We're going to draw one side, two sides. So there's one set of parallel lines. Now I have to draw another set because it says two. So we'll go with green. So we're going to draw one and two. All right, so I have two different polygons, one with one set of parallel lines and then the other one with two sets of parallel lines. Now I could have also done this. I could have gone one, two, and then I could have drawn one and two. And then there's two sets of parallel lines. Now this is a rhombus because, well, I was trying to make a rhombus. It's more like a crooked diamond. But anyways, so this has one set of parallel lines and this has another set of parallel lines. Whereas this has two sets of parallel lines, but it doesn't matter because even if they're going straight or if they're crooked, they're still never going to intersect because I've made them directly next to each other. All right, so we're going to go to our share and show.
Trying to get these to be...
Oh, hi, how are you?
Oh, hi,
Hey,
how are you?
I was actually having some fun with my walking sticks, and actually it really makes an interesting point that I thought would be a fun math riddle I wanted to give you. And the question is, can the same two
and intersect at the same time? Well, first of all, let me just tell you what those words mean. I want to tell it to you casually, and then we'll more formally tell you. That's right, I'll put a tuxedo on. It's a joke. All right, here we go. So two lines are parallel if they kind of look like this, meaning that they're always the same distance apart, and they never ever will pass through each other. Now, two lines are perpendicular if in fact they cross each other and form right angles. And two lines intersect if, in fact, they just cross somewhere, somehow like that. So now the question really becomes, is it possible that the two same lines can be parallel, perpendicular, and intersecting at the same time? Well, now let me tell you very, very carefully what these three words mean, even though now we have a kind of a sense of what it is. Parallel lines. They're lines that appear to never cross or ever meet. They're always the same distance apart, and they will never form any angles. So those are examples of parallel lines. Let's say, look, kind of like what I showed you with my walking sticks. Perpendicular lines are kind of the opposite. Perpendicular lines, perpendicular lines. They are intersecting lines that do cross, and they form right angles. Perpendicular lines, perpendicular lines, perpendicular lines. And you see, they cross, and see, there's that special secret symbol that we use to show that they form right angles. And so there you can see all those right angles, and they cross just like that. So one's kind of horizontal, and one's exactly vertical. Now, intersecting lines is kind of a general version of that. Intersecting lines. They do cross or meet, and they form angles. And so here's some intersecting lines. Woo! Woo! Intersecting lines. And they're the intersecting lines because they do cross, they meet at a point. So, can the same two lines be parallel, perpendicular, and intersecting at the same time? Well, no, they can't. Do you see why? Parallel lines will never, ever meet or cross each other. So therefore, you can't be perpendicular, which means they cross, or intersecting, which means they cross, and be parallel, which means they don't cross. So the answer is no. But you could be perpendicular and intersecting because they both have the feature that they cross or meet each other. So the answer really is that no, lines that cross can be both intersecting and perpendicular, but lines that cross cannot be parallel. Boop, boop, boop. And there is the answer. And the cool thing is that you can see all sorts of examples of parallel and perpendicular lines just in our everyday world, even if you're thinking about walking sticks. Here again is what parallel looks like. Here again is what perpendicular looks like. And anything, as long as they cross each other, that's intersecting. Have fun finding parallel, perpendicular, and intersecting lines in your life. And I will see you soon.
Okay, so we're going to continue on with our share and show. And if you go down to question number 1, hopefully you have your book open still. And it says, which sides appear to be parallel? So you want to think to yourself, parallel. That means they will never cross over. So just like Mr. Berger said, Professor Berger, so we want to look at parallel. So you're thinking to yourself, which pairs of sides appear to be the same distance apart and will never cross? So if you think about that, we know that A and C will never cross, because if we draw that out, you can see these two will just continue on. So A and C, and then if we go to our other lines, we can see that B and D, they will never cross. Okay, so those are parallel lines. They will not ever be intersecting. Down at number 2, it says, look at the green sides of the polygon. A polygon is a closed figure with line segments that has no curves and that's closed. And it says, look at the green sides of the polygon. Tell if they appear to be intersecting, which means they would cross, or perpendicular, which means there's a 90-degree angle and they're intersecting, or if they're parallel. So you're looking at the green. So here's the green and here's the green. And if you drew them out and extended them, they would be parallel. Now we're going to look at this green one. So if you actually extend it out, and I'll extend it out using green. So if I extend it out here, this green, and I extend this green out, you can see that they do intersect. And they are not intersecting at a perpendicular 90-degree angle. If we go to number 4 and we extend out the green lines, you can see right here in the corner, I could put, it's not perfect, guys, but I could put a little square here in the corner. Just kind of move that over for you. And you can see that that would be perpendicular because it forms a 90-degree angle. Okay? All right, so let's go and let's move down to number 5, and it says on your own, look at the green sides of the polygon. Tell if they appear to be intersecting, perpendicular, or parallel. Write all the words that describe the sides. So you're looking at this green side, and if you drew it out, would it be intersecting? No, because they would never cross over. Are they perpendicular? No, because they would never intersect or cross over each other. They are parallel. Then we look at this green, draw out your green, and you can tell that they do intersect, but they intersect at a very special corner, which is right here. So hopefully you putting a little tiny square right here because that is a 90-degree angle. So it's very special intersecting, it's perpendicular. And then if you go here and you draw these out, you would see that those also intersect, but they intersect at a larger than 90-degree angle. So they're an obtuse angle, which means they are not perpendicular. So we're going to continue on to the next page, and it says use the pattern blocks A, B, C, D, and E for questions 8 through 11. So we have Chelsea wants to sort pattern blocks by the types of sides. So we're looking at all of the sides. And it says which blocks have intersecting sides. So hopefully you would be able to look at A, and you would see if you drew these out that these sides, they do intersect each other. Okay, so they do have some intersecting lines. B, if you drew these out, they have some sides that are intersecting. C, if you drew these sides out, they would be intersecting. D, if you drew these sides out, they would be intersecting. And E, if you drew these sides out, they would be intersecting. So every single one of those have intersecting sides. Then it says which ones have parallel sides. So this one, you actually want to draw some lines. So we know that we have to find another side that won't intersect with this. So if you look right here, you should be able to see that these are parallel sides. If you go to C, let's just choose this way. That has a parallel side. If you choose D, that has parallel sides. Oops, sorry, I should have moved that up a little bit. Oops, not really grabbing that very well, am I? There you go. All right, so then we're going to go back to our straight lines. And we're going to look at E. And E, obviously, a square has parallel lines. So all of those have parallel lines. Now, if we look at B, I'm just going to draw out all of B. B has no parallel lines. You can see that all intersect. Okay. Then the next one, let's see if I can grab all these and clear them. I don't think I can. Sorry, guys. So I'll move it down so we have some clean areas. So this one, the next one says, which blocks have perpendicular? So now we're looking at perpendicular. So we're looking for something that has a 90-degree angle. Okay, so I'm going to give you a second. Figure out which one has a 90-degree angle. Hopefully you see it. So that would be E, has a 90-degree angle right here. If you did that to this, you would see that that would be an obtuse angle. If you did that with this right here, that would be an obtuse angle. If you did it here, that would be an obtuse angle. So the only one that has perpendicular is E. And the last one says which blocks have neither parallel nor perpendicular sides. So no sides like this and no perpendicular like this. And hopefully you see that that would be B. No parallel, no perpendicular 90-degree angles. Okay, so we're going to move on to number 12. It says on the box, at the right, how many pairs of edges are perpendicular line segments? So you're looking, oh my goodness, perpendicular line segments. So first of all, you're looking at how many pairs of edges. Goodness, so pairs of edges. So here's an edge, 1, okay, 2, 3, 4, 5, 6, 7, 8, 9, 10, oh my goodness, 11, 12, 13, 14. Wow, there's a lot. So you go through and count them and see how many you get. So at the box on the right, okay, how many pairs of edges are perpendicular line segments? Perpendicular line segments. All right, so I have 24 pairs. That's crazy. That one's going deeper. So if you got 24 pairs, congratulations. 13. Can the same two lines, oh, this is just like we did math on the spot. Can the same two lines be parallel, perpendicular, and intersecting. So can they be parallel? Can they be intersecting? And can they be perpendicular? And we saw that no, they cannot, because they will be crossing when you do parallel, or when you do intersecting and perpendicular. All right, so we're going to go on to comparing representations. So I am a pattern block that has 2 fewer sides than a hexagon. Hexagon has 6 sides. I have 2 pairs of parallel sides, 2 of them, and 4 right angles. So it says, which shape am I? So we know that it has 2 fewer sides than a hexagon, so that would be 4. We know that it has 2 pairs of parallel sides, which means 2 parallel. And then it has 4 right angles. So go ahead and find it. So if you go down below, hopefully you can see right here. So it says, write yes or no on the table to solve the riddle. Hopefully you went through and you found it using your table. So 2 fewer sides than a hexagon for the triangle, no. Exactly 2 pair of parallel lines, no. 4 right angles, no. So that takes the triangle out. Then we go here, and it says 2 fewer sides than a hexagon, so it has 4 sides. Exactly 2 parallel lines, absolutely. But does it have 4 right angles? No, it does not. So then we go next door to our diamond. Yes, yes, and once again, no, because these are pretty much the same shape here. Then we go to our square. Does it have 2 fewer than a hexagon? Absolutely, 4 sides. Does it have 2 pairs of parallel lines? Absolutely, each side here and here. And then it has 4 right angles. Yes, you could put little boxes. Those all form little L shapes. Then we go next door. 2 fewer sides. Yes. 2 parallel sides? No, because we know this would go up and trap a little man up top, so that's a trapezoid. And then 4 right angles? No, it does not. Now, does this have parallel lines? It absolutely has parallel lines. But does it have two fewer sides than hexagon? No. Does it have exactly 2 pairs of parallel lines? No, it does not. And then does it have 4 right angles? No. So the only one that works would be the square. So we're going to go down, select the shape that has 1 pair of parallel sides. Mark all that apply. So it has to have at least 1 pair. Go ahead. You're right. A, B, and D. C is the only one that does not work. So you're going to move on and you are going to go to your practice and homework. You're going to pause me for a minute and then you'll come back and I'll give you all the answers. All right, so welcome back. So it says look at the dashed sides of the polygon. Tell if they appear to be intersecting, perpendicular, or parallel. Write all the words that describe. So number 1 was parallel. Number 2 is intersecting and perpendicular. Number 3 is intersecting. Number 4 is intersecting. Right, here's 5. It's special because it has a 90-degree angle, just like up here. Perpendicular and intersecting. And then we have parallel. Number 7 was A, C, and D. Number 8 was B and C. Give some example of perpendicular lines outside or inside your classroom. Hopefully you're looking at like your house, you're looking at your windows, you're looking at your door frames, you're looking at maybe the table you're working at. And then we go to our lesson check. Hopefully you finished this while you pause the video. Number 1 is it has 2 pairs of parallel lines. Which sides are parallel? You have A and C, and you have B and D. Your spiral review for 3 is a pentagon. It has 5 sides. Then you have 1 for the angles that are greater than a right angle. Line segments, there are 8 line segments, and then over here, the fraction of the shaded part is 1/6. I hope you guys had a great day for your math lesson, and I will be seeing you in just a couple minutes for another lesson. Take care.